Okay, for the homework, don't forget it's each learning plan or each problem set we have problem sets, 13 total. And the problems to work on is going to be in download. And if you print this out and so forth. In chapter one, only problem needs to be done with these four for turning in. Once you move for practice, knock yourself out. But only needed was 5, 6, 7, and 10 on chapter one of Crossing River Dogs. And today we're going to basically go through chapter two material. And all you got to do is 3, 6, 7, 9, and 12. Again, if you see if some look interesting to you, feel free to play with them. And then, of course, these definitions. So that's what's going to be needed for being turned in on Monday by midnight. I also, again, we're going to be working I'm going to be working predominantly out of the assignment section. That's where the learning plans are, problem sets. And I have posted under problem set one, basically the onboard work I did. And because I'm not real happy with the way the videos are being processed and timely uploaded to get access to. I'm downloading them, showing up to YouTube, and basically embedding a YouTube video again on the goes along with this item. Oh hush. Of course, if you want to see a bigger version of it, sometimes these things work, sometimes they don't, but nothing else. You can always click on YouTube here itself, and it'll take you to YouTube, and you go as big as you want then. Okay. I'm gonna clean the screen up here. That's what it's got here. All right. See what's in the chat here. Okay, Sam's okay. I'll try one more time explaining this since it's a bit tough for me to draw on paper. I say use Photoshop, and I did question 1, 2, and 3 in problem set 1 and save the problem documents. Then I did question 4, 5, and then when I close the document, I didn't save effectively my program. Hopefully that clears up for me. Yes, it does. But what I was trying to get across, Sam, is you're doing. I mean, I have no problem with you doing more problems than being required. I kind of understood what you're saying there. I just wanted to emphasize that you're doing a lot more than needed. Sometimes not a bad thing. I'm not going to deny that. So cool. We're all caught up. Let's see, who's out here now? Let me take a look. Paulson, Jeski, Eshke, Sam, and Tristan. 2, 3, 4, 5, 6, 7. All right. 7 out of 15. Kind of depressing here, but oh well. I shall live. I shall live. Okay. So again, what I asked for today was it wasn't need to be. You didn't have to have it done, but just to make efforts or work on the chapter 1 questions, learning problem set A, 5, 6, 7, and 10, to allow an opportunity if any of them gave any specific heartaches. Like number 7, I just can't figure out. And I do will allow a few minutes or a little bit of time each class period to look at problem sets that were assigned. Of course, I kind of showed in one of the what do you call it? Learning plans. In one of the learning plan copy PDFs that another instructor put up, has a good definition for heuristics. So you may want, again, if you haven't gone through those modules for learning plan 1, learning plan 1, I'll kind of like, actually, this is basically these two guys combined. But if you haven't yet, kind of like just page through this guy, instruction problem solving part 1 and part 2, you may find the answer to heuristic. These other questions are contained within, well, this one, and this one are definitions within the textbook itself. In the textbook, you find them. I'll also kind of like, today we'll be doing chapter 2 material. So I'll probably kind of like in my usage, kind of like demonstrate what that is, and what that is. All right. So with that being said, rubbish. Okay. Is there any particular hotspots or issues or heartaches in problem set 1, crossing the river with dogs, chapter 1, problem set A, 5, 6, 7, or 10? And these are not due until midnight Monday, 11:59 p.m. Good, glad to hear that. It's basically a line diagram connecting all other letters and stuff, and giving each one a distance label, and and basically using those as roads and pathways from A to F, or A to C, or A to 39, B to 39. I was very stuck on the 5th problem. Okay, the 5th problem. Let's see, what was the 5th problem? Let me get my book open. Oh, by the way, I was able to give myself a copy of the textbook. So that'd be the stone necklace? Yep. Hey, interesting. I think I'm just going to go down and bring it up. Well, speaking of stone necklace, this is kind of like what they're saying. Let's see what we have here. He laid out a stone circle in a big circle, a stone necklace in a big circle. So basically, here's my necklace. Okay. And she was trying to figure out how many stones there were. And this is the strategy I used. I drew it out, drew a circle, and she says she lost count, but she noted that the 6th stone was directly opposite the 17th stone. Okay. Now this is a solve by diagram. Right. Was directly opposite the 17th stone. So I just drew in a bunch of circles, and I wanted to see how many stones were there from basically 6 to 17. And started here, basically I counted these stones up. And got 11, which means essentially Now if I do a little bit of symmetry here, a little flip siding it, my very next stone would be opposite this one. The next stone will be opposite this one, and and so 1, 2, 3, and which means that I go opposite 17. This would be the 11th one going this way. So going off to 6, I had 11 stones going to 17. Going 1 off 17, I'd have another 11 going up to there. So that means each side would have 11. So 11 plus 11 would be 22. That was the approach. That was my approach. My way of doing it. Is that the only way? No. There's other ways of doing it. But that's the way that worked best for me. Yeah, fix it. Good. All right. Any other ones? The rock climb one was just like the inchworm. How'd the race go? Is that number 7? Wow, that's pretty good because that one took me a little bit of time to think about. I eventually got it. Good point. Well, let me just give you out the order though. So I mean, should have gotten again. I have the letters. S should have been the winner. Whatever S goes towards, I think Sabrina. Then A followed by R, followed by L, followed by the I name, followed by B. So S was first, B was last. So SARLIB should have been the order. Then you also got to find what their distances were, also respectively. Good to hear. Okay, looks like we're off to a start. So let's go and start working on what's called systemic lists. Did anyone else look at problem 8 about the handshakes and think of COVID? Actually, I think probably because it wasn't assigned, so no, it's not assigned. I don't look at it personally, but then yeah. I'd rather do that now. So let's just insert another page here, and I'll just move it up there. All right. And I'm not going to do the whole thing. I'm just going to give you the approach. So again, we were given 20. It was a 26-foot climb, and the thing is, we go up 5 feet, and then down 3 feet. So much like the inchworm, plus 5, down 2, that'd be then 6. Up 5, down 2. And just keep on doing that basically that up and down until somewhere along the line, you're gonna get 26 feet. And realize every time you go up, each up was, how long did it take to go up? 5 feet in 2 minutes and down 10 seconds. So every up was 2 minutes a time. And every back down was 10 seconds. I think it was 2 minutes. I think it was 120, 2 minutes up. I mean, she climbs 5 feet in 2 minutes and then slips back 2 feet in 10 seconds. This pattern, 5 up and 2 down, goes all the way to the top. Okay, so I think you find a mistake. Just the time's wrong. Yeah. So basically, every time you do a 5, you know, that's 2 minutes. That's 2 minutes. Just got to add them up, and of course, every time you slide back, 10 seconds, 10 seconds. But you got to really keep track of your up, down, back 2, up 5, back 2, up 5, back 2, up 5, 14, and so forth. And just just shimmy up. Basically, you gain 3 feet, but like the worm on that last trip, you got to be careful because you may not have the slide back. Okay, sounds good. Okay. Systemic list. It's so I guess pretty good on that one then. Okay. So systemic list, it's just systemic list. It's just a organization of no thought, ideas, etc. All right. And again, I think the best way is by showing examples. So I have here we go, systemic list. So I have a couple, and I'm not sure if this one fully meets the criteria for a systemic list, but I like this one because I do solve kind of by making a list, being organized. So I'm going to give you all a minute and just read the problem. So just give you a chance to read through the problem and the situations between Albert and Bernard. $249, so I'll chime back in at 250-ish. Have you got the answer yet? Yeah, lousy camera. All right, so hey, you got two guys made new friends with Jess. And they want to know her birthday. Jess gives them 10 dates. So let's list them. That's why I think it's a list. We have May 15, May 16, May 19, June 17, June 19, July 14. Uh-oh, that's what I wanted. Go. Come on, be nice. Why don't I stop moving? That's okay. I'll live. July 14, July 16, August 14, August 17. Is that it? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Those are the dates that Jess put out. And let's see, she told Bernard the day, and she told Albert the month. So see, for Albert, he was told either May, June, July, or August. Bernard must have been told the 14th, 15th, 16th, 17th, or the 19th. All right. Then she asked if they can figure it out. Okay. So Albert first says, I don't know when Jesse's birthday is. Makes sense. May, June, July, August. I don't know. But here's a clue. But I know Bernard doesn't know either. Okay. So realize Albert knows what month. He knows if it's May. Okay, sure. I tell you that. But Albert knows what month. He knows it's either May, which is 3 days of choices, 2 days in June, 2 days in July, or 2 days in August. So he knows what month it is. How can he say he knows Bernard doesn't know it either? Well, actually, we're kind of like crossing the line between lists and elimination. And the idea is why Albert can say, I don't know what it is, but I also know Bernard doesn't know it. Remember, Bernard only knows a date. Oops. It'd be May 19th as being the answer. No, but good try. Okay. So let's look at okay, Albert knows what month it is. But let's look at for Bernard's side out. So let's just say it was the 14th. If the day was on the 14th, would Bernard have been able to guess the answer without knowing the month? It was the 14th. Would Bernard know what month and day it was? Well, so here's no month. So would he be able to tell? If it was the 14th, it could be either July 14th or August 14th, right? If it's the 14th, without knowing the month, you can't narrow it down. How about if it's the 15th? What if he was told it was the 15th? There's May 15th. There's nothing in June. There's nothing in July, and nothing in August. Okay. So in this case, May 5th, the 15 is the only one that appears once in the entire set. I've got multiple 16s, multiple 14, multiple 17s, and multiple 19s. So like I say, Albert knows what month it is. Okay. So since he knows it's, so I have to assume that with Albert, it's either June, July, or August. Because if it's either June, July, or August, Bernard couldn't, with just knowing the date, wouldn't be able to isolate it or narrow it down. Because it's June 17th or August 17th. I don't know. June 19th, May 19th. I don't know. And so forth. So the 15th was the only day that was unique. That would have been independent of the month. So by Jesse saying, I don't know what it is, but I know Bernard doesn't know what it is either, would mean that the month is not May. So this clue one. No, the 14th is there August 15th? Oh, hang on. Did I miss one? Yeah, I did. Dang, nabbit. I hate when that happens. What there is not June 19th. How the heck did I screw that up? My logic still works, though. I can't even read properly. Okay, wait, the same logic still applies. Now what date is the only one out there? The 19th. Okay. So 19th is the only one out there. All right, so I didn't screw up too badly. Okay. Which again means with Albert's statement, it can't be May. Albert's, by saying he doesn't know what Jesse's birthday is, but neither does Bernard, basically rules out May because 19 would be the only. Oh, now I see what you're. Okay. Okay. Grace, your May 19th wasn't the answer, was the what day is unique. Sorry about that. Okay. So then Bernard says, at first I didn't know, but now I do. Okay. So again, so we narrowed it down to June, July, August. June, July, and August. And now Bernard knows what it is. So using the same idea, between the June, July, and August, is there a unique date that's not repeated in any of the other, that's not repeated in one of the other months? And now I do have other proper dates down. It was given the 14th. It had to be the July, August. It was given the 15th. That only exists in August. The 16th is in. It was also covered in May. Let's see. 17th is in August and June. And 15th was also doubled in May. There was another one. Oh. Okay, I need to send me my notes some more. All right. That's because of mix up. And what else do we know also? Ugh. Colors here. That was a single day, everything, and this was a single day and everything. Actually, if Bernard had been given the 19th or the 18th, he could have figured it out. I really got to start using my notes more than just trying to use notes for initial checks. Yeah, 19th and 18th were onesies. So the 18th and 19th were onesies, then you stand back more. For onesies, if he was given either the 18th or the 19th, he'd have been figured out. Jesse knew it couldn't have been the 18th or the 19th because it wasn't May or June. All right. And that's the first, I didn't know when Jesse's birthday is, but now I know. If you know, then I know too. So what do you think is the date going to be now between July and August time period and some previous clues? Oh, there's August 15th, July 16th. Aha, is right. Oh, yes. Okay, July 16th is one call. Oops. Oh. Okay, someone says July 16th. That was Dustin. No, it can't be the 14th. Any other thoughts? Anyone else? Do I chime in? 14th is both August and July. Yep, so definitely gonna be that one. So if it's 14th in both July and August, so that means, so now, let's think about this for a second. Because they both carry the 14th, so Bernard would know what it is because couldn't if Bernard's giving you the 16th, 15th, or 17th, he would know what it is at this point. Because right now we're down to 2 months. We will at the 14th. If Bernard knows what it is, so that means it's down to the 16th of July or the 15th or 17th of August. But Albert says he knows what it is. Now, if it's the 15th or 17th, could Albert figure out what it was if he knows August? Yeah. Dustin on the 16th was got it correct. Because if the month was August, and Bernard knew what it was, it has been either the 15th or the 17th. Because right now the 16th, 15th, 17th are one date only to choose from. That's why you rule out the 14th. But for Albert to know, we have to get it down when there's only a single choice in the month, which gives us July 16th then. I managed to screw that one up royally pretty good. Amazing when you get some dates mixed up. A lot of concepts that I, partly obstructed here, did not understand. Okay, well, the good news is we'll be doing more of these guys in the elimination crowd. Well, let's go back and just do a quick rehash. Yes, I will. I was going to go do that. All right. The first clue was, of course, all Albert knew was a month. Could be May, could be June, July, or August. Bernard knew the date, the 14th, 15th, 16th, 17th, 18th, or 19th. Now Jesse was able to say, because he knew the month, that he didn't know what the answer was, but he also knew that Bernard didn't know the answer. Because if Bernard was given the date, if the date was either the 18th or the 19th, even without the month, you'd be able to figure it out because there was only one 19, May 19. There's only one 18, June 18. So with Albert saying, I don't know what it is, although I don't know what the date is, Albert that is, he's saying Bernard does it because Albert knows because Albert was given either July or August. Because in July and August, I'm saying he was given July or August, and which does not contain 18 or 19. So Albert was basically pretty able to deduce that the two possible dates it can't be is the 18th or the 19th. Because right now, let's just say let's say the month was July. Well, that means either the 14th or the 16th. So if Bernard was given 14, if Bernard was given the 14th date, well, that's either July or August. If Bernard was given 16, it's either July or May. If the month was August, same with 14, 14 was either August or July, 15 was either August or May, and 17 was either August or June. So a single date alone wouldn't help you. So Albert was able to make the conclusion that, hey, it's a date that has multiple repeats. So the deduction was, since there's multiple numbers, it can't be this one or that one. Because if Bernard was told the 18th, he'd right away know June 18th. If Bernard had been told the 19th, he'd right away know May 19th. So Albert, knowing what month it was, knew it wasn't June or May, and knew it couldn't have been the 18th or the 19th. So with that, we were able to basically eliminate May and June, which not only is for July, due dates and August due dates. So now Bernard would have thought about that. Oh, Albert just eliminated May and June. So now here's Bernard. Bernard says, I know what it is. Now look between July and August. Again, they both show the 14th. So that means Bernard would have been given the right. Had to be given the 14th, 15th, 16th, and 17th. Right. So he's narrowed it down. And by him saying it's not, I know what it is, that ruled out the 14th. And again, why did I rub those other guys? It rules out the 14th. Oh, yeah. Right. Okay, so that rules out the 14th. So it can't be August 15th or 17th, right? But again, going back, Albert knows the month. Okay. So again, like I said, maybe we have a script written down. So Bernard knows what it is. So he's given the date. So he can narrow it down. It has to be a number that doesn't repeat itself between July and August. That rules out 14, so it had to be the 15th, 16th, or 17th. But then again, Albert knew. So yeah, so that eliminated the 14th because Bernard knew that eliminated the 14th as an option. But Albert knew the month. He knew the month was July. If it was August, if Albert's month was August, Albert wouldn't know what it is because it's either 15th or 17th. Oh, Lord. So for Albert to have known, it had to have been a month with only one date as an option left over. Yes, but we ruled out May, though. And we ruled out June. Oh. The reason it can't be 15th or 17th is because Albert knows the answer. If it had been it could have been August 15th or August 17th, but then Albert couldn't come back and saying, I know what the date is also. Check. Okay. If we got time, we'll go back and talk about this one some more at the end of class. So maybe it'll get clear as we go on. We'll come back to this guy. All right. We'll come back to him. All right. What's this guy? I have no idea. Okay, this one is kind of more of a list, though. List. Okay. And how we kind of we can solve things by freezing certain columns. So let's look at Leslie here. Has 25 cents in her pocket, but does not have a quarter. If you can tell her all the possible combinations of coins she could have, that add up to 25 cents, she will give you 25 cents. Woohoo, that's big of her. All right. So let's do a list. Now, 25 cents means we have, well, what can make up a 25 cents? No, quarters, which we don't have any. Dimes, nickels, and pennies. Okay. Now we know we don't have any quarters because she told us that up front. So we're just going to freeze quarters and we're just going to make them all the same number. Okay. And most people I would think would probably go work their way from right to left in this case. The easiest way to make a quarter is to have no dimes, no nickels, and 25 pennies. Okay. So let's go and freeze. We're going to freeze dimes for a while. We'll eventually work our way over there. So if we have 25 pennies, that's one option. If we want to have a nickel, well, that's going to equate how many pennies? So how many pennies does it make a nickel? 20. Okay, yeah. So really, as a list, it's really just kind of like building it up. All right, let's get ourselves another nickel. So we increment the pennies down by another 5. Okay. All the while, I'm going to hold my dimes to 0. Okay. So that's what freeze. Let's freeze our dimes for the time being. Okay. Let's get another nickel's worth of pennies out. Because 3 nickels makes 15 cents. 15 plus 10 is 25. And 4 nickels is 20 cents. Plus 5 makes a quarter. Okay. So, okay. Basically, I ran holding my dimes frozen at 0. I basically used up all my pennies, converting the nickels. So now let's go with some let's get a dime. Of course, to make a dime, you need what, 2 nickels? Well, now let's work on nuts. Let's work on one dime. And now we'll freeze this guy at 1 for a while. Go back to 0 nickels. So if I have 1 dime, that gives me how many pennies then? To make a quarter. Let's see, dimes 10, 25 minus 10, that'd be 15 pennies then. And do it again. Let's knock this down by a nickel. Knock it down by, that should be a 1, by the way. By a nickel. 1 dime plus 2 nickels and 5 pennies, yeah. Still frozen. 0, 3. So now, again, we kind of like reset the clock a little bit. So when I say reset, that means we upped one of the quantities and then froze it for duration as we iterated through the other portions of it. Let's go to 2 dimes. That's 20 cents. Means I have 5 pennies. Just turn a bunch of pennies into nickels. And I think that is all we have. So one of the strategy is to, like I said, freeze a column. Of course, this is frozen the whole way at 0. Is a freeze a column, which allows you then to systematically go through the other columns or the other pieces parts to get your list, and then it's a matter of adding them up. Okay, what's the guy I got? 1, 2, 3. Let's go with the color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, 12. Yeah, 12 ways. I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yeah, 12. Oh, I put the team written down there. Yeah. So when they say freezing a column, freezing data just means holding a column set and not moving it, which allows you then to do the other guys first. So there's 12 ways to make 25 cents using dimes, nickels, and pennies. Yahoo. All right. Okay, so let's see. Frisbin. Long story short, throwing a frisbee through a hoop. And what do we got here? We're throwing three frisbees being thrown, 3 attempts, and 3 bins. Set up 20 feet away. That's nice to know. Okay. And each bin has a different score. Some bins are worth 1 point, some bins are worth 5 points, some bins are worth 10 points. So let's see, how many ways can we score on Frisbin? So let's do a 1, 3, what? 1, 5, and 10. 1 point, 5 points, and 10 points. And total. Always better give you some more grids than too few grids. That may be enough. All right. Now, could we gone 10, 5, and 1? Yeah, this order doesn't make a lot of difference. So again, three throws. So there's a couple ways of getting your points. You could get all 3 of your frisbees in the 10 hole, the 10-point hole, which of course gives you 30 points. And again, like I said, do the freeze. So hold something 0 for a while. And so now let's go and make one of them 5, which means there's 2 left. So nothing in the small hole, 1 in the 5 hole, and 1 in the 10 hole. That gives us 25. Or we have 2 in the 5 hole, 1 in the 10 hole, which gives us 20. All right. And finally, we get them all in the 5 hole, which gives us 15. So then everything I good, any other combination I can get in the second column, the second and third column. So now let's go and let's do a couple ones there. So I'm going to look, use the 1 column and freeze it. And again, work on the 5 and 10, which means nothing in the 5. If 1 is in the 1 pointer, that means there's 2 left to go in the 10 pointers. And I'm multiplying this 10, 10, and 1, 21. And of course, take 1 out of the 10, put it in the 5, 10, 15, 16. Then 2, 0. Go for 11. And now I've done all I can between the 5 and 10 again. Okay, now let's increment the 2 here. So put one, move another one into 1 bracket. That means we'll start over with 0 and 10, 5 and 10. That's what it's 10, 11. How many points is that? That is 12. Okay. Then 2, 1, 0. That 10 to 5. That gives us a 5, 6, 7. And it looks like this guy. 4, 3. And there. So how many? So did I miss any combinations? All 10s, all 5s, all 1s, and everything in between. 1 and 2, 2 and 1, 3, 0, 1 and 1, 2 and 0, 1, 0, 0, 0, and 0, 1. So yeah, then you just add them up. So we got 1, 2, 3, 4, 5, 6. Yeah, lose track. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then when you score, although check for repeats. Do we have any duplicates up there? 30, I got 21, 20, 15, 16, 11, 12, 11. Yep, no duplicates. Then you just add them up. Again, be a list and a little bit of math and process. Now you got multiply 10 by 3 and or 10 by 2 and 1 by 1 and so forth, and get your scores. And depending on how it is written up, there may be some we may get duplicate numbers. Notice that the totals aren't in high to low necessarily order. They do mix up a little bit. So you always go back and check I'm not saying your math, but again, there may be some combination where they both add up to 12, or they both add up to 17. And if you get two numbers the same, that's not a different way. That's not a different score. The answer is not how many different ways, it's how many scores can be made. You always got to check for duplicates. Yeah, I'm done doing this one. What? All right. I gotta be honest, I have never read a Shakespearean book in my life. All that old English stuff just doesn't thrill me. Hark, thou balconies, something breaketh. I don't know. What the heck's a breaketh? Okay. So let's figure out how to do this kind of in a list. We have 5 books to read. We have Richard III. I think I'm going to over here. We have a Richard III. We have The Tempest. Macbeth. Midsummer Night Dreams, and Othello. Now, with those of you who may have had some statistics, you may have recognized this as a combination problem. With 5 items, how many unique ways can I arrange it in 3 ways? And if you're familiar with statistics, you'll know a way of doing this in about 20 seconds. Unfortunately, this is not a statistics class, it's a logic class, so we don't have that luxury. However, we can do a table, again, by freezing. Because if I choose Richard III, basically for my second book to write, I can do either Tempest, Macbeth, Midsummer Night Dream, or Othello. I'm just going to do those 3 guys as my first combination. Okay. Now, whether it's Richard III, Tempest, or Macbeth, it will be the same as the Tempest, Macbeth, or Richard III, or Macbeth, Richard III, the Tempest. I mean, it's all the same combination. So what we can do is, again, do some freezing. I want to freeze, because I have more room and left, I'm going to freeze Richard III in the Tempest. My third book combination could be Midsummer Night Dreams. Okay. I still got room to the left, so keep Richard III frozen, the Tempest frozen, and Othello. So if I choose 2 books, Richard III and Tempest, Then I have three other options: Macbeth, Midsummer Night's Dream, or Othello. I'm not done with Richard yet. Now, instead of Tempest, let's kind of like concentrate on Macbeth. Okay, I'm not going to do Tempest anymore. I need 3 books. Here we go. Here's my 3 books. Richard the Third. I'll freeze Macbeth. And then there's my other one. Still one more I can do with Richard III, though. Interesting to note, as for the pattern here, okay, we had Richard III, there were 6 of them. The Tempest was 3. Going for freezing. Then we went down to 2 for Macbeth and 1 for the Midsummer Night's Dream and Othello. Interesting. All right. So now we're done with Richard. We've done every combination of Richard III with the Tempest, with Macbeth, Midsummer Night's Dream, or Othello. So let's concentrate now on the Tempest. Okay. Now I don't need to do Richard III again because Richard III. Now we're repeating ourselves because we did Tempest with Richard III a couple levels up. So let's do the 3 easy ones. Okay. Well, let's basically chill out this guy. Freeze these 2 guys, and we'll move him. Let's see, is there any more? Now, I know I got Richard III done, and there's 6 Richard IIIs. Right now, there's only 1, 2, 3, 5 Othellos. There should be 6 Othellos. So obviously, it must have another one. Well, by freezing Macbeth, I've got Midsummer Night's Dream and Othello. So I guess I need to also then move this guy over. Yep. Need more, unfortunately. Let's see, I got 1, 2, 3, 4, 5, 6 Othello. I got 6 Tempests, 6 Richards, 1, 2, 5 5 Macbeths, 5 Midsummer Night's Dreams, and 1, 2, 3, 4, 5 Othellos. Okay, so I've used up all my Tempests. Wow. That's it. Quick check. Everyone should be up there 6 times in some way, shape, or form. And I see 6 X's under Richard, 6 X's under the Tempest, 6 X's under the Macbeth, 6 X's under Midsummer Night's Dream, and 6 X's under Othello. So. Adds up to what? 3's 10? 10 ways you can come up with 3 different books to write papers about. In reality, what would happen is, of the 5 books, you only read 3 of them, and those are the 3 papers you write about. TMO. There's some checks going on here. Oops. TMO. Yep. There's T, there's M, and there's O. Yep, that's up there. Like I said, I'm not sure that I should be proud of this or not, but at least showing my illiteracy of classical readings, Like I said, I have not read a single Shakespearean anything. I've watched some movies based on Shakespeare's works, but I've never read any of the books. Anybody see anything that I may have missed? Pretty sure I have a pretty comprehensive list there based on my checks. And based on the systematic way of, like I said, freezing specific columns as you work the other ones. Okay. I've noticed that you kind of start dividing. Notice that you kind of start dividing the times you freeze by 2. Look in the first column at 6 and 3. Oh. Observation wise. Yeah. Just yeah, because the first 3 over here, I was working these guys. I ran out of them, but I ran out of them for this one. But for these 3, I have not run out of moving things over there. So that's when I then went and froze those guys, worked those, used up those combinations, and just worked the way down. It's little. Yeah. Yeah, you do notice patterns after a while. All right, here's show you another list on doing these guys, and it's called what the heck is okay. In many ways, it's referred to as a decision tree. Another one of those statistics, nasty statistics things. In the previous one, we're doing combinations. A combination is the recognition that I'm going to make that PMO is the same as OMT. That's a combination. Combination is the same letters, just in a different order. Order doesn't matter. What we're going to do next is look at what we refer to as a permutation. Okay. Basically, A, B, C, D. Is not the same as B, A, D, C. Same letters, it's the same combination, but different permutation. That's when things get really weird, because the confusion comes is what do you call lock? You call it a combination lock. Okay. Well, the combination lock, 1, 2, 3, that's a combination. If you put in 2, 3, 1, it won't work, because it recognizes that as a different arrangement. So actually we've been lied to. A combination lock is really a permutation lock. It's not a combination, it's a permutation. So where a list is good for a combination, for permutation, a tree is best, a decision tree. working on at the premise that for my first letter, your first option is basically anything you want. So let's do that. Let's do, if I can fit this all on one page. A, B, C, D. All right, A, B, C, D. All right. So I picked my letter A. So in this case, for the first one, I chose A. So that means A is no longer on the table. So for my second choice, I have B, C, and D for an option. B, C, D. And I chose B. Which means now for my next option, I have either C or D. As an option. I chose C. So now I got left, now you don't have a choice. So A, B, C, D is one possible permutation, one possible arrangement. Now, of course, so now I have A, B, D. So if I do this to the next level, A, B, D, that means the only thing left over is going to be the C. So A, B, C, D, A, B, D, C. And also by doing these decision trees, you kind of like look at the previous step on what goes in. And what I mean by that, here we have I have A, then C. Well, what's left? Well, it's got to be BD. That's a B, by the way. Yeah. And of course, D and then B. If I went the AD route, what's left to be the BC. All right. So right now, for that first set, I've got myself ooh, did I lose something? No. Yeah, no, 6. So ABCD, ABDC, ACBD, ACDB, ADBC, and ADCB. See that 5 times fast. All right. And similarly, go down the list. If my first letter was a I want to do this not. I want to keep that up. Oh, well. If my first letter is a B, what is left for my next choice? Well, if I get rid of the B, it's got to be either an A, a C, or D. Then, well, it has to be either C or D left. And of course, D and C. If I go the BC route, well, it has to be A or D. And of course, that'd be D and that'd be A then. BD, well, what's above it? A and C is left. And what's below the A is C, but C is A. So, another possible combination of permutation. BACD, BADC, BCAD, BCDA, BDAC, and BDCA. Hey, I feel like a Canadian, at least up the peninsula, Michigan. And similar, so that's another 6 possible ways of arranging A, B, C, D. And if location or position matters, that's a permutation. They're saying here that the location is significance. Okay. That ABCD is not the same as ADCB or BACD. They're all different. Yahoo. And some you do something for A, for C. So for C, it makes you start off with and build off that guy. And for D, and again, build from there and outward. So a decision tree, or what's the book called? Book has a different name for it. I'm using a statistics term here. The book calls it a tree diagram. Tree diagram. But it's working on this idea that once you choose a letter, it kind of like starts reducing your options. And A, B, C, D. We were chosen D first. That means your next choice is either A, B, or C. And if you've chosen C next, now you're down to A, B. Or choose B. You're down to A. So actually, then, so like in this case here, chose B. What's left over? A, C, and B. I chose C. What's left? A or D. I chose A. What's left? D. Okay. So in each line, you're going to have A, B, C, D. It's just what way it arranges itself is the trick, the game. But these tree diagrams are a pretty powerful way of again organizing a systematic way of cycling through all the options. I think that was it. Oh, what's this guy? Same one. Only need one. Let's see. Them smaller. Let's see. Yeah. So Tanya has 7 skirts. 5 are solid, 2 have patterns, 6 blouses, 4 are solids, 2 are patterned. She'll mix the ensembles. Anything with solids, anything goes. Only we're a pattern with a solid if there's a common color. Showing where a pattern with a solid, there's a common color. So it sounds like you should never mix a pattern with a pattern. Not being the fashion person I am, I don't know if a pattern with a pattern is a fashion faux pas. Could be, or maybe it's just a personal preference. So let's see what we have. So we know a solid with solid, a pattern with solid with matching color. If a color. So that means the blue or green floral skirt has to be with a blue or green solid blouse. The black or red plaid skirt has to do with a black or red blouse. Okay. That also means the blue and red blouse has to go with the blue or red skirt, or green and yellow blouse. I'm sorry, blouse goes with the green or yellow skirt. Okay. So let's see, what do we have? So I chose to do this in a slightly different way. And have a better way of doing it by all means. So I have my blouses. And skirts. Good. So we have, what blouse do we have? We have a white blouse. We have a blue blouse. A green. A yellow. And we have a blue and red. And green and yellow. All right. Now, according to her color scheme, a solid will go with any solid. So what color skirts do we have? We have blue, green, black, red, and purple. Okay, for the skirts. Gotta find a more compact way of doing this. Blue, green, black, red, purple. All right. So with a white skirt, she can match it with two white blouse with 2, 4, 5 skirts. And see, let's check on the florals on the skirts that have color. Any of them have white, so none of those guys are applied. So with the white blouse, she will not have any patterned skirts. So with the blue, she doesn't say anything about wearing the same color with each other, like blue with blue or red with red or anything. So for the blue blouse, means she's also going to have the blue, green, black, red, purple, and the blue and green floral. Green, okay, that's a solid. It'll go with any solid. And green's in it, so the blue and green floral again. Yellow. all solids are good. And there is no yellow in any of the skirts. All right, so now let's see. We have no, nothing about matching floral with a pattern with pattern. In fact, she'll only wear a pattern with a solid. So we have blue and red blouse, and we have a blue and red skirt. Green and yellow blouse, and we do have green. No, we just have green. We don't have a yellow, so all we have is green. So I guess now you just add them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 outfits. 25 outfits she can make. Five, six, six. Oh, that's why. Yeah. So 25 outfits she can make, or 25 ensembles of the clothes, of skirts and blouses she has. So I think this qualifies as a list. You also could have done a tree diagram with this one. You could have gone about the tree diagram where shoots. We have white one, and of course then different white blouse, and of course the different and so forth skirts. Could have done it that way. One for each blouse. White blouse, red blouse, green blouse, and so forth. You could have done it with a tree diagram too. It's all a matter of preference. But this, I think this qualifies as a list, systemic list. Tree diagram would worked also. So yeah. Let's see. Let's go to 4:15, I believe. Is that correct? Yeah. So lost lost myself here. Here you go. Let's look at the scale from a clean sheet of paper. And so we can figure it out a little more carefully. First of all, it helps to have things written down correctly. Let's see, we have May 15th, May, June, July. Yeah. Done July and June. May 15th, May 16th, May 19, 17, 18, July 14, July 16, 14, 15, and 17. All right. So again, recall, Bernard knows day. What's his name? Albert knows the month. All right. And Jesse whispered the day to Bernard, the month to Albert. Okay. And that's all they know. Okay. So Albert's first comment says, I don't know what her birthday is, but he also knows Bernard doesn't know it. Which means at this minimal number of information, the only way Bernard would know the answer is if he's given a date that is one of a kind in the months. And if he's given, Bernard was given the 15th. If he was given the month, the date 15, that means it could be either May or August. He was given it was the 16th. And like I said, Bernard doesn't know what month it is. Okay. So it could be the May 16th or July 16th. Given the 17th, which one of those 2 days? If given the 14th, again, a day in 2 months. So if Bernard was given that it's the 19th, hey, I know the birthday because it's only 119. Or if he was given 18, okay, I know it's May. It has to be June 18th. So Albert is given the month, so he has a set of dates that he's looking at, which means, think about Albert's viewpoint. He's given June or July or August. And in that group is not the 18th or 19th. Okay. So that's why he says he doesn't know, but he also knows that Bernard doesn't know it. Because Albert's thinking the dates are 14, 15, 16, or 17. Which from Bernard's viewpoint is anywhere in a number of different months. Which is why we can eliminate May and don't cross too much May and June. Because if it's not June 18th, if it's not the 18th, it can't be June. If it's not the 19th, it can't be May. That way we give it the entire month. Albert's clue is based towards 2 months that it can't be. So Albert's clue based the laws throughout the May and June time period. Okay. Which is half the numbers, which is good. Then Bernard comes back and says, at first I didn't know when the birthday was because it wasn't the 18th or 19th. But now he knows. Because Bernard's also thinking the same thing. Hey, you know what? If Albert knows that I don't know it, that means it can't be the 18th or the 19th. So Bernard also has basically mentally eliminated May and June. But now he says, I know it. Okay. So Bernard knows it. Well, Bernard to have known it, it means it has to be either the 15, 16, or 17. Because it was the 14th, it'd be the July or August. And he doesn't know the month. So Bernard knows it. Albert's thinking, hey, that means it can't be the 14th. Now Albert comes back and says, oh, I know it too. That's because he knows the month. So the only way that Albert would know also the answer is if it's July, because the 14th was eliminated, and by default or by the process of elimination, it has to be July 16th for Albert to also know it. Hopefully that helps, or makes it a little more or lesser muddy. Which means Albert was told July, and Bernard was told 16. Yeah, hope that helped. Hope that cleared up a little bit. Dave, I was recording this. Yes, I was. Good. All right. And one. Oh. And so I hope that helped. This helped. That helped a little more. So we leave. What is scheduled for Monday? Well, Monday, and it's getting wild, really more most couple in assignments. All right. Okay, so for Monday, problem set 1, fully attempted. That includes the chapter 1 and chapter 2 problems, and the 10 or so of A, B, C, D. Let's just pull it up. Grab it up, range. Here we go. Okay. So problem set 1, LP1. So the definitions, 5, 6, 7, 10 of chapter 1, 3, 6, 7, 9, 12 of chapter 2. And these are what I'll be using to grade them with. So those will be fully worked or the best. And again, on Monday, I'll have some time set aside to discuss questions on. I think we pretty much have chapter 1 done. Any questions on the chapter 2 problems? So this heuristic definition is found in one of those PowerPoint PDF files in the learning plan. And these are mostly in the textbook. Freezing is kind of like what I could not find it in the textbook. However, I did kind of emphasize the thought of freezing a list item in today's presentations. And so by midnight Monday, you need to have uploaded it into the computer. Blackboard. All right, get out of here. Cancel. 26, that's right. And then we will, on Monday, start talking about chapter 3, which is process of elimination. Maybe we may start matrices also. Maybe. Chapter 4. But that's in chapter 3. Because chapter 3 is has some really bizarre stuff in it. Those puzzles where you change numbers, letters into numbers. Yeah. Oh yeah, always be a lot of fun. Oh yeah. So that's expectation for Monday is we're questions on problem set 1, get those all set up to turn in Monday night. And then we're attack chapter 3 and maybe start chapter 4. And that's the plan, Jack. With that, like I said, I'll also will get, they go, all right. No later than Monday. Definitely have the, let me bring this stuff.